Hello friends, welcome to our online channel. My name is CCCJadhav. So in previous lecture we have seen that manual part programming. So today's lecture we will see the chapter number 5, fundamentals of NC system. So in that we will see evaluation of the NC and retrofitting, elements of NC manufacturing system, concept of work 0 and machine 0, types of NC system, structure, drives and other devices, what are the steps in the manufacturing, their advantages, disadvantages, flexible manufacturing system, elements of flexible manufacturing system, some application and advantages and disadvantages in flexible manufacturing system. So we will start from the first point, that is the introduction of numerical control machine. So according to Electronic Industry Association, numerical control is a machine which we are going to provide that part program to that machine which is created from the CAD database, and we are going to directly give as input to NC machine for the further manufacturing. It is a system in which actions are controlled by direct insertion of the numerical data at some point. The system must automatically interpret at least some portion of the data. Okay, so this is the basic information regarding the numerical control machines. Means we are going to create one part manufacturing. For that we are going to prepare one CNC part programming, and simply we are going to give the input as this program for the further manufacturing. And that program, that numerical control is just controlled by direct insertion of the numerical data. Whatever we are giving that input data as a geometrical data or as a programming data, they will just control by itself. Okay, so this is introduction of the numerical control. So we will see the evaluation of the NC and retrofitting, how they are inventing, how they are developing that NC machine system. So first inventor John Person from the MIT, that is the Massachusetts Institute of the Technology. First of all, 1949 US Air Force asked to MIT to develop the numerical controlled machine for their work. Okay, this is the first evaluation. After that, 1952, the first prototype of the NC machine is demonstrated using the punch tape input. This is one of the input. Here we can give the signals to that NC machine to what to do or what to do for that particular manufacturing. So puncher tape is one of the just input device to we have to provide the some information to that machine. So this is one of the platform where we can give input for that machine. Okay, next, after that in 1959 MIT announced that automatic program tool programming language is launched. Okay, so after that in 1960 direct numerical control eliminate the paper tape punch program, and instead of that they are using directly program files or soft files they are using for the manufacturing. They are directly send to that file to machine tool without using the paper tape punch. After that in 1970 CNC machine tools and distributed numerical control machines are invented. In 1980 graphics geometrical model based on the CAM system introduced. Means whatever that manufacturing system is there, software is there for developing 3D model, creating the wireframe database, creating the solid model database, surface model database. For that purpose in 1980 CAM system is introduced in our era. In 1990 price drop in CNC technology. 1997 PC Windows based CNC system is introduced. By using personal computer we can handle all the numerical control machines information, or we can give the input as a program by using the PC Windows in 1997. After 2009 we are using the Windows 7, and later on we are using 8, 10, like this. We are just updating. Okay, so this is the first just evaluation part. So you can see here, this is the first numerical control machine by MIT Institute. Okay, so you can just imagine the size of this machine even that when many person is there greater than the person height, that program or the machine size is bigger than this height. Okay, so just you can imagine the first CNC machine, how it works. Okay, so this is just a history part. So we will see the numerical control of the machine tool. What is exactly a numerical control means? Means it is just we are going to creating the one CNC part program for our desired part production purpose. Okay, so in that we are we have to give input as a part program by using various numbers, letters, symbols. We are controlling that system. Okay, that means numerical control means we have to control that whatever given program by using these machines for the given design manufacturing production. Okay, so numerical control of the machine tools is defined as a method of the automation in which various functions of machine tools, various function means we are going to creating any drilling, milling, holding. Okay, like this functions of machines which machine tool are controlled by the numbers, letters. Control by numbers means we are giving some preparatory code, G code means suppose I will give you the G0 rapid traverse means by using these numbers, letters, we are controlling this numerical control machine for given desired manufacturing. So this is just overview about the numerical control. So you can just see here, this is our basic drawing. From that drawing we want to create the actual production. Okay, so from this drawing we have to create first NC part programming. This is our NC part programming. From that we have to create the one tape, because this is our input device for the tape reader. So this is a tape reader, paper tape reader, and from that this is actually our control machines. From that CNC or VMC, whatever that numerical control machine is there, and from that we are giving signals to directly our machines. So this is machine. So this is the basic figure related to elements of the NC machine tools operation, how that NC machine operation is carried out. So you can just imagine, you can just see this is our part drawing. From that we have to create the NC part program. For that we have to create one punch tape or program tape for the further reading purpose, and after that paper tape reader he will transfer the signal from the machine's controller, and controller should be started transfer that signal to actual manufacturing machines. Okay, so this is the overview about the NC machine tool operation. So next part is the elements of the NC manufacturing system. So you can see here, this is the one figure is there. In that there are three part is their main part. So first part is the programming, second machine control unit, and last one is processing equipment. So this is the three elements, major elements of the NC manufacturing system, in which first part is part program, second is machine control unit. In that we will see the data processing unit and control loop unit. We will see in details in next slide. And last one is the processing equipments, that is nothing but your actual numerical control machine. So what is the functions of the program? First, it is used for the part programming machining, and machining control unit is control the whole the process, and last one is the perform the processor. So we will see the start from the first point, that is part program. The part program is a set of statement, means we are giving some input to that machines in the form of the NC part programming, and it will be converted into signals, and that signals moves to the machine, and it machine will be started moving the spindles, whatever given operation driving, and that is our required output. So part program is nothing but a set of statement of the machine tools control system can interpret and convert it into them signals that moves the spindles and drive. Okay, the program input device is the mechanism for the part programs to be entered in the NC control. The most commonly used program input devices are keyboards, punch tape, reader, and networks. These are some example for the input devices for the part program. Okay, so we will take the one example. You can see here a part program, one program is made, or one example, one block is made. You can see here first letter N10 means indicates the sequence number for that given operations. G01 means that linear interpolation mode. Already we have seen that G code, M code, in that we are going to give a linear interpolation mode. For that we are entering here G01. X and Y, this is the coordinate related to the axis, and F is a feed rate for that particular operation. So we can see here one part program is a series of the coded instruction. Coded instruction means already we have seen that this coded means for what you want for that particular that in blocks. So I want to just linear interpolation related to the x5 2.5y and feed rate. So this is a coded instruction required to produce a part. It controls the movement of the machine tool and the on-off control of the auxiliary functions such as the spindle rotation, coolant on-off. Already we have seen that the some miscellaneous code for the coolant on-off, spindle on-off, spindle rotation. That coded instruction we are going to using for the part programming. The coded instruction are composed of the letters, numbers, and symbols are arranged in the format of the functional blocks as in the following example. Already we have seen this type of the example we are going to use in the actual part program. Okay, so this is the first part, that is a part program. In the program input devices, the program input device is the mechanism for the part programs to be entered into NC control. The most commonly used program input device is punch tape reader. Whatever required operation is there, suppose drilling is there, and for the drilling purpose we have made one CNC part program. Okay, likewise previous slide is that n sequence there by using letters, numbers, that we have seen that previous, that n10 g01 x coordinate, y coordinate. Likewise we have created for one block for the drilling of purpose. So I want to convert this program into the signals, and from that signal machine will be run and machine will be doing that their operation. But what is the way to convert these signals program to the signals to the machines? So punch tape reader is one of the most commonly used input device for the converting this part program to into the signal to the NC machine. Like this, there are different there are more input devices by using for the at the time of the NC machine, but in the NC part programming, punch tape reader is the most common input device for converting this part program to signal to the NC machine. Okay, so you can see here, this is the one punch card example. This type of the punch card we have created after the NC part programming, and we are just sending the signal to the NC machine for the further operations. So you can just see here, the person is sitting on the machine and they are creating the punch tape from the given that part program, NC part program. So before starting NC machine, we have to create the punch tape from that program, and that punch tape we are going to insert in the machine, and that punch tape will be created some signals, and that signals will be transferred to that machines. Okay, so we will see the punch tape sequence of the processing steps is called as a part program. Okay, we are going to create the block. Before starting any block, we have to give some sequence number, that n is letter for the sequence operation. So sequence of processing steps means block number 1 2 3 4 5 like this. Okay, so this is called as a part program. The medium to write a part program in NC machines was a 1-inch punch tape. Okay, so there is some rule for that, writing the part program to the in punch tape format. So medium to write the part program in NC machine was 1-inch punch tape. NC machine coding system uses alphabetical characters, numerical, and other special symbol in part program. Already we have seen that alphabetical character means that G code, N, F for feed, S for speed. Like this, we are using the miscellaneous code, preparatory code, and numerical means value, that coordinates, and other special symbols. Okay, now we can see this is some of the example for punch tape. Already you have seen that like this punch tape is there in industries, they are using for creating manufacturing the different part. So this is one of the just specification reading of that punch tape. Description is there binary, in terms of binary letters. So for this is for this only understanding purpose, we are not going to use any at the time of the programming. So you can see here, this is the tape reader, oldest tape reader. This is also punch tape reader, a phonics system. So second part of the NC management system, that is machine control unit. the machine control unit, it is a basically heart of the NC system. It is used to perform the following functions. Basically, it is the heart of the NC system, means it is a control everything, means it is the main part of the part program, NC part program. So we will see one by one functions. It is used for the coding, read the coding instruction purpose. Okay, whatever provided that part program as an input to the machines. So after that input, machine control unit is a first work is read the given coding instruction one by one and decode that coded instruction for the further purpose or manufacturing process, and provide the decoded information to the control loops of the machine axis of motion. Once the given coded instruction read one by one, suppose block number 1 is read by the machine control unit, after that they are going to decode that coded instruction, and after that decoded information is to transfer the machine axis through control loops for the further operations. Control machines tool operation. This is the functions of the MCU. You can see here, this is our MCU. MCU consists of the 2 unit DPU and CLU, and this is our actual NC machines. So after given program as input to the machine control unit, already I have seen that the function of the MCU. So MCU includes the two subtypes or two data, the data processing unit and control loop unit. So we'll see what is the basic function of the data processing unit and control loop unit. So first of all, we will see the DPU. DPU reads the program, decodes it, processes the information and passes it to the control loop unit. Once that input program, part program decoded by using DPU, and they will process for information, they will create some signals and they will pass us to the loop unit, control loop unit. And what is the function of the CLU? It will be convert that information to the control signals and drives the mechanism, receives feedback about the position velocity and instruct the DPU to read the new instruction. Suppose I want to create, or I want to traverse to 1.2 second point. So I want to create one block number 1, that is a N10 G00, that is a rapid traverse X0 Y0. Okay, this is the first line to only the rapid traverse tool. Second, N20 G01 linear interpolation X20 Y20. I want to traverse this tool 00 to 2020. Okay, so whatever given instruction, coded instruction, first function of the DPU, just read that code, decode that code instruction and process to information to and pass it to the control loop unit. Once that instruction is coming to CLU, that instruction converts into control signals, and that signal is derived through mechanism, means that G01 X20 Y20, that signal is once received the MCU will give that signal to that spindle, and spindle moves linear interpolation along with X20 Y20 like this. If any problem is there, that they will send the one feedback regarding the position and velocity of that particular operation, and again CLU instruct the DPU to just correct, or whether if that instruction is correct, then go for the next instruction, read the next or new instruction. Okay, like this each and every block they will sending the signals to DPU sending that information to CLU will sending the signal to machines, and they will send the feedback, and like this they are going to complete all the part program. Okay, so this is the basic function of the MCU, that is a machine control unit. So in that DPU already we have seen that it include at least input device, punch tape reader, reading circuit, checking logic for the reading information purpose, decoding circuits, distributing data, interpolates, which is supply velocity commands between successive points taken from the drawing. In the CLU, position control loops for all the axes, velocity control loops, auxiliary function control such as coolant on off, spindle on off. Like this some function should we have in CLU and DPU. Okay, so this is the second unit. So we will move towards the last, that is the processing units, that is your actual CNC machines or machining. Last process, that's processing equipment. So first the programming, in that we are just collecting the information, programming. Just after that EMC, we are just reading that information, code it, decoding, then transfer the signal to the machines, and after the last point, just we are going to the manufacturing. So these are the elements of the NC system. So next part is the concept of work zero and machine zero. Work zero means it is a location where we are actually not started the work, but our tool is near about the work where we can start the operation. It is also called as work zero, job zero, and floating zero points. So actually we are not starting the operation, but we are yet to start, or we can start the operation at this point. Okay, here we can start the operation. And machine zero means it is the origin of the coordinate system which is defined by the manufacturer. Means we can define one reference point in near about the workpiece, but not actually on the workpiece. So some distance away from the workpiece, we can create the machine zero point, which is having that coordinate system is a 0 point, and that point we are starting the moving tool at a certain some distance away from the workpiece as a safety distance, and then we will start our operations with the reference to work zero point. Okay, so it is the origin of the coordinate system which is defined by the manufacturer. They can't be changed. It is also called as fixed zero point. Okay. So this is the work zero and machine zero. Work zero means our tool is near about or near to the workpiece, and machine zero means our tool is far away from the workpiece. Okay. So next part is classification of NC system. First type is work and tool relationship. In that, machine with rotating tool, milling, drilling. Second is machine with rotating workpiece, lathe. Machine with non-rotating workpiece, that is non-rotating tools, shaper, planer. Fourth one is unconventional machining, EDM, ECM. Other machine tools like CMM. Next type, based on the motion type, point to point, straight cut, countering. Based on the positioning, absolute, incremental. Types of control system, open loop, closed loop. Based on the power supply, electric, hydraulic, and pneumatic. So this is the just classification of the NC system. In next lecture we'll see in the details. So for today's lecture this is enough. Thank you.
Hopefully you might have enjoyed the lecture. Then please do like the video and know your thoughts in comments. Please do share this video among your friends, and don't forget to subscribe to our channel. After subscription you can press the bell icon to never miss the notification regarding our new videos. Thank you so much.